Hi everyone, welcome back to our channel. In the previous video, we have discussed about the preparation methods of ethers. In this session, we are going to discuss about the properties of ethers. As usual, the properties of ethers are studied in two different categories. The first type of property is physical properties of ether. Physical properties. Under physical property, the very important property is the boiling point. The boiling point of ethers. How the boiling point is varies and all that. Ethers usually or generally they are exist in a liquid state and is highly volatile liquid and it's a good solvent also. Organic solvent and has some important physical properties. Under that, boiling point is very important. Now, what is the how boiling point of ether varies compared with the corresponding other group of elements or other group of molecules like alkenes, alcohols, etc. How the boiling point of ether varies with alcohol, how the boiling point of ether varies with alkane and all that. I am considering few examples for the explaining this thing, physical properties of ether. Okay, I am consider the common or the simple example that one is ethyl groups. Ethyl means compound contains 2 carbon. Okay, compound contains 2 carbon. CH3OCH3. What type of compound? Yes, this is ether. Name of the ether is the common name of ether is. The Ayurvedic name is diethyl ether. Diethyl ether. Okay, and let's consider another one example. CH3. What's the name? Ethane. Next, CH3, CH2, OH. What type of compound? Compound contains hydroxy group. That the word is alcohol, ethanol. When we compare these 3 compound molecules, diethyl, ethane, and ethanol, these are the isomers. I think you are already studying in the first year. These are the isomers. What type of isomerism observed? Yes, functional groups differ. Functional group isomers. Okay, these are the functional group isomers, and these has different physical property because of their different type of attachment between the molecules of these. When we compare the corresponding ethers and ethanol or the isomers of ether and alcohol, ether does not form hydrogen bond. There is no hydrogen bonding in ethers. But in case of alcohols, we observe hydrogen bond. Hydrogen bond between the molecules of the alcohols. One molecule of ethanol make a hydrogen bond with another, and they make more or the bond strength between the molecular force or molecular interaction is more. Because of the more interaction more boiling point is observed compared to these two. And what is the order? Ether has very low boiling point. Next, ethane, the next. The alcoholic isomer shows more boiling point compared to the corresponding ether. The reason is hydrogen bond. Okay, I will consider another one example. The next is CH3, CH2, OCH3. Is the name of the compound? Yes. One is methyl, one is ethyl, therefore methoxy ethane. Methoxy ethane. And consider CH3, CH2, CH3, propane. Next, consider CH3, CH2, CH2, OH, propanol. Propanol. When you compare these three, ether has low boiling point, alcohol has high boiling point. These two alkanes and ethers has small difference in their boiling point. Very small difference. Okay. This is a very important thing for your exam point of view. The boiling point of ethers. So this is the very important things under physical properties. Okay. Next, we move on to the chemical property. Other thing is not important. Another extended to these things to the solubility. When we observe the solubility, solubility of alcohol in water as same that of solubility of ether in water. Okay, that means the rate of solubility of alcohol in water is equal to rate of the solubility of ether in water. Okay, the reason, what is the reason of solubility? Again, there is a hydrogen bond. Alcohols are soluble in water because of the ability to make a hydrogen bond with water molecule. Similarly, ethers are soluble, not readily soluble, little bit, small amount of solubility observed. Only lower ethers are soluble. The higher members of ethers are insoluble in water, as in the what we observed or what we studied in alcohol. Same thing is observed. In case of alcohols also, lower alcohols are soluble in water and the higher members of alcohols are insoluble because alkane chain, as the alkane chain increases, insoluble part is increases. Because of that, solubility decreases. Correct? How the lower ether make hydrogen bond CH3 O CH3 has one pair of electron and H2O. Better to represent this. There is a hydrogen bond. There is a possibility of hydrogen bond. When we increase the alkyl chain, insolubility is observed. Solubility decreases. Okay, solubility decreases. These two are the very important things for example under physical property. Next, we move on to the chemical properties of ethers. The chemical properties. There are two important chemical properties are observed, and these two are given in your syllabus. According to your second year's syllabus, there are two important chemical properties. What are the important chemical properties under ether? The one important property, reaction towards hydrogen halides. Hydrogen halide. Hydrogen halides are represented as a reaction towards hydrogen halide. Okay, this is the first important reactions under chemical property. The under this thing R dash ether react with hydrogen halide and forms alcohol first. Correctly observe. Cleavage of hydrogen halide bond take place. Correct. Cleavage of hydrogen halide hydrogen and halogen bond. Undergo cleavage. The attack on the alkyl part, the more carbon or alkyl compound contains more carbon that readily react with the halogen and forms alcohol and alkyls. Alkyl halides are formed. Alkyl halides formed. This alcohol not remains as alcohol, again react with hydrogen halides what we use and again forms RX and H2O is generated. What is the conclusion? What is the conclusion of this reaction? Whenever ethers are made to react with excess of hydrogen halide, it produces corresponding alkyl halides. Okay, alkyl halides. I have considered a small example. The simple example is CH3OCH3 react with hydrogen chloride or hydrogen iodide. Best example for this type of reaction. I'm explaining after the completion of this reaction why we should take hydrogen iodide, and little bit amount of heat is necessary for this reaction and formation of CH3I. Two molecules of CH3I is formed and water is eliminated. Okay, hydrogen halide is formed. This is the important reaction. Then what is the order of reactivity of hydrogen halide towards this one? Let us discuss about this one. That one. What is the order? Very important for your competitive exam purpose. Order of hydrogen halide or reactivity order. Okay, reactivity order of hydrogen halide towards ethers. Okay, order of hydrogen halide towards ether referred to as reactivity order of hydrogen halide is more reactive, iodide is more reactive than bromide, than chloride. Okay, this is the order. This is the order of reactivity. Okay, towards ether. The requirement of the order is for the study of the different reaction. We consider the higher number of ether, then we should need hydrogen iodide for the conversion of alkyl halide. Okay. And the temperature is also needed. One condition, and the second condition is temperature. The reason of temperature is cleavage of oxygen and carbon bond. Temperature is needed because to cleave R and oxygen bond. Cleavage of this bond we need temperature. Okay, therefore I will represent this one. Next, we move on to the second type of the reaction. And in this case, we observe another important condition, that is we studied generally. These things are general things, but under general things there are some important part is there, that is nature of ethers. Nature of ethers. If we consider the symmetrical ethers means R equal to R dash. If we consider symmetrical ether for the reaction with hydrogen halide, there is no difficulty or twisted things because only alkyl halides are formed. But in case of the unsymmetrical ethers are considered, R is not equal to R dash. Okay, there are two important things under reactivity towards hydrogen halide. One is symmetrical ether are equal to a dash, asymmetrical. The second thing, asymmetrical ethers, R is not equal to a dash. In this case, there is small difference is observed. That is, I am considering one example. Okay, consider an example. Tertiary alkyl part CH3, 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 O, CH3. Okay, tertiary butyl is a part, tertiary butyl, and this is the methyl part. Third butyl methyl ether. The common name of this compound is third butyl methyl ether. When asymmetrical ether react with hydrogen halide and more amount of heat is required and supply the heat also. In this case, the smaller part of the ether, smaller part means less number of carbon. Here we observe only one carbon. Here we observe, okay, adjacent side of the oxygen, there is only one carbon on the right side of me, and at the left side we observe the 4 number of carbon. Which one is the bulkier part? This is the bulkier part. It's a smaller part. The smaller part of the ether always form alcohol. That means this part goes out. The reason, very easiest thing, this one. If you know the basic part of the organic reaction, it is electron donor, this part is electron donor, electron donor, electron donor. Whenever these parts donate electron, then cleavage of carbon-oxygen bond become very easy. Therefore, cleavage of carbon-oxygen bond take place when we supply small amount of heat. And when cleavage takes place, CH3O minus is formed, react with H plus and forms. What is the product? Yes, this is the methane bond. Alcohol is formed. Remember that smallest part of the ether forms alcohol and the bulkier part forms alkyl halide. What is alkyl halide? I am using iodide, therefore it forms third butyl iodide. Okay, third butyl iodide. Okay, this is a very important thing under this reaction. Okay, this is very important thing for your competitive examiners also. Therefore, please remember the reactivity towards hydrogen halide in case of asymmetrical ether. Okay, next move on to the last part of this chemical reaction, that is electrophilic substitution reaction. I am give the one homework for you, that is how anisole react with. Anisole means aromatic ether, how it react with hydrogen halide. What is it? Okay, this is the work for you. Please study about this reaction and what may be the product form in this case. Okay. Next we move on to the second type of chemical reaction, electrophilic substitution reaction. Electrophilic substitution reaction. You are already well known about the electrophilic substitution reaction. Many times it is repeated in your organic reactions. There are 5 important reactions. One is chlorination or halogenation. Second is nitration. Third one is sulfonation. Fourth one is alkyl acylation. Okay, Friedel graph, alkylation. Next one is acylation. Okay, Friedel graph, alkylation and acylation. In this session or in this video, I am going to discuss about only 2 things: halogenation and nitration. Sulfonation, alkylation, acylation, as similar as that of this one, these 2. Therefore, that is also your work. Okay. Please study about on this sulfonation and alkylation and acylation. Okay, I am complete this video by after the halogenation and nitration. I am consider halogenation first. What happens when ethers undergo halogenation? Again, as usual, electrophilic substitution reaction is only for aromatic, correct? Aromatic compounds. Therefore, I am consider aromatic ether. Aromatic ether is very familiar one or well-known compound. That is, what is the name of the compound? Aromatic alkyl ether. What is the name of the compound? Common name is anisole. Anisole is the common name of the compound. And what is the impact name? This is the smaller part, this is the bigger part. Therefore, first we use smaller part, correct? Methoxyphenyl, correct? Is it correct? Okay. Just observe the impact name of the anisole. Okay. Again, it is about for you. When anisole react with hydrogen iodide, there is no cleavage of oxygen alkyl part or anything. Halogenation, I consider Cl2 is halogenation. Cl2, Br2, I2, anything. When we use the halogen and aluminum chloride, anhydrous aluminum chloride is the catalyst, then chlorine attack on the which part of the result? Again, it is about for you. Please guess the position of this anisole for the electrophilic substitution reaction. This anisole is similar to phenol. Why? See here, phenol, benzene, OH, correct? OH group is electron donor. CH3O group is also electron donor. Because of electron donating groups attached to benzene, that creates or that gives ortho or para position for the attack of electrophile. Therefore, these are called ether part is known as ortho-para directing group. Okay, ortho-para directing groups. This one is ortho-para directing group for electrophiles. Due to that, chlorine is always attack on Because of that, it produces two products. The two products are Cl ortho derivative. The next one is para derivatives. Okay, two different products are formed. Okay, again as usual, para product is major. Why? It has some electron density. It pushes the negative part. Due to that, it goes to para. Okay. Next is nitration. Second, nitration. Anisole react with. I am consider again anisole. It is a major and important compound under organic ether. HNO3 nitric acid in presence of concentrated H2SO4, it produces again ortho para derivatives. Okay. NO2 plus ortho derivative derivatives. As similar these type of reaction, sulfonation takes place, alkylation takes place, acylation takes place. That is work for you. And please identify the product formed under sulfonation, alkylation, and acylation. And also there is another one work. What is the name of this compound? Okay. Please identify the name and IUPAC name as or common name, anyone. And complete these things, properties of ether, along with the topic. Okay, this topic is completed in after the completion of alkylation and acylation. Thank you for watching.